Hey, I'm Alan Tsao, and welcome to the student question of the week. Here's another kinematics question related to physics. And if you guys have any questions, you're welcome to send it to, you can look at the description for the email, but it's questions@bothellstemcoach.com. This is the kind of stuff that I do for my students. If you're curious about how it works, for me helping out students whenever they have questions, I do this all the time regularly, so I just thought I would show you, and maybe you guys would learn something a bit about how I break down problems for my students. So we have an observer stands next to a front edge of a first carriage of a train. So we got a train here, and let's draw out the picture of the train. Normally I just use a dot for everything, but we got a carriage of a train, and we have an observer. This is we'll call this the front. We'll say the train's going to be moving to the right, and we have a person here. And basically, what's going to happen is this train is going to be traveling to the right. Now, when the train starts to accelerate. So uniformly means constant acceleration. That means we're going to use our kinematic equations, right? Because our kinematic equations are only applicable when the acceleration is constant. So we're going to assume the initial velocity is 0, because we're going to assume that it starts from rest. Otherwise, we probably can't solve it. It takes 5 seconds, and let's for the first carriage to pass. So basically, this part has to travel to here, and that takes 5 seconds. That's what they're telling us. And assume that all carriages are the same length. What is the time taken by the 10th carriage? So that means the 10th carriage to pass the observer. So this is like number 1, this is number 2, ... this is number 10. And this was a little confusing on the wording. There's a multiple choice answer to this part of this question, but I like to solve it without the multiple choice. But because of the wording, what they mean is the time it takes to go from here to here. That means this has to pass by there, and then this guy has to pass by there. And we would like to know what is the difference in that time, from the time it takes from the front of the 10th car to pass the person to the time that the back of that car passes that person in the front here. Okay, so when we're doing this, we're always trying to think about what pieces of information we're trying to figure out. And that's why I teach you guys, or I teach my students to list out all the variables of what I know about a motion. Now, we know something about this motion. So let's take a look about the first car, something about the first car. What information can we glean from here? We could probably solve, okay, so the initial velocity is 0. The acceleration is unknown. We know the t is 5 seconds. So we need another piece of information here. We don't know the displacement, or I'll get back to the displacement. We don't know the final velocity. We don't know the acceleration. So in order to solve anything, we definitely need 3 pieces of information. And so what I would say here is, while I don't know, I don't know the length of the car exactly, but I do know that the lengths of the car are the same. So let's just pick a number. I'm just going to pick 1. You can assign it a variable. That's probably the more rigorous way to do it. But a nice shortcut is just say, like, well, I'm going to give it a number. I'm going to just pretend that the cars are 1 meter apart, because the answer should be the same regardless of it, as long as I kind of scale that length. So let's just say it's 1. And then from here, I can then solve for everything else. Now, what would be the most useful to solve for? One thing is you could solve for all of it. However, the final velocity at this point isn't going to be particularly useful once it gets to this point. It's probably more useful to know the acceleration, because I know the acceleration is the same for the entire motion. So the acceleration is what we're going to solve for. So we're going to use this set of, what equation relates these 4 variables is going to be something like this equation. This is the one kinematic equation that has these 4 variables, the 3 quantities I'm known, and then the one I'm looking for. So this is 0 times 5 plus 1/2 a times 5 squared. And just using my calculator, this is going to tell me that 1 is equal to 25 over 2 times a. So a is equal to 2 over 25, which is equal to 0.04 meters per second squared. Okay, so that tells us what the acceleration is. Okay, so now we need to know something about this motion. So let's look about this motion from here to here. Let's imagine the cars traveled, and we want to know from here to here, basically how long that looks. And let's think about what we know. Okay, we know the displacement is 1 meter, because from here to here, during that motion. The acceleration is 0.04 meters per second squared, because we said the acceleration is the same the whole time. And we would like to know the time. However, I'm missing some information. I need to either know the velocity at this point by the time it gets to here, or I need to know the velocity at the end, because I need 3 pieces of information to solve for that fourth one, right? So let's go ahead and maybe solve for this one at the velocity here. After this train has moved all the way to this point, how fast is the velocity going? Right? Because that would be the initial velocity, the velocity at the start when it first passes by that person there. Right? So then we're going to think about, okay, let's do a motion from, say, here to here and talk about how fast it's going by the time it gets to this point. So we're going to do another kinematic scenario. See, there's a lot of kinematic scenarios, but it's backtracing on what we know and what we're trying to figure out. And I'm trying to figure out one of these numbers. You could do this number. Honestly, it doesn't really matter. It's just probably more traditional to find. Or you could find both of them, honestly. So let's look at this motion from here to here. Okay, from here to here, the displacement is 9 because 9 cars have passed, right? Like 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the beginning of the 10th car, but if you think about what the length of that is, it's going to be 9 of them because each of these cars is length 1. The initial velocity is at rest. The final velocity is what we're trying to figure out, and the acceleration is 0.04. So then we can solve for that by using what equation relates these 4 variables, right, is going to be this equation. And so you're going to say v squared is 0 squared plus 2 times 0.04 times delta x, or delta x, which is 9. Okay, so then if I solve for v here, I get 2 times 0.04 times 9, and then I'm going to take the square root of that. And I'm going to get 0.849 meters per second. Yeah, okay. All right, cool. So that is the velocity at this. So when this, by the time this part of the car gets to here, it's going at 0.849 meters per second. Okay, awesome. So that tells us the velocity at the start by the time that the front edge of the car has passed the person is 0.849. Okay, so think about that. There's by the time this guy's gotten to here, it's now moving at 0.849 meters per second. And now we have enough information. Let's go ahead and solve for the time here. Now, the tricky thing about this one is the equation that relates to these is this equation directly, right? So you could say 1 is equal to 0.849 times t plus 1/2 times 0.04 is 0.02 t squared. Oh, actually, let me double check my math and just use the calculator and double check a few things. I already made a mistake. Let me double check. This is supposed to be 0.08. I did that too fast. I was thinking 1 out of 25. So I messed up that. And let's fix this part. So I apologize for messing this up. 0.08. And so let's get... Like honestly, the amount... So what I get here is 1.2 meters per second. So this is 1.2. Okay. Now, the thing about this is you can do this. This requires quadratic formula. This is 0.08. And then let's fix that. Okay, cool. Now, you can use your calculator to solve it. That will give you the time. That's one way to do this. You can also, if you don't like using the quadratic formula, just that's not something you're strong at. But, you could, one other trick I tell students is like, look, if math is not your strong point, and you don't want to use quadratic formula, one of the things you can do is solve for this guy first, because solving for time using the quadratic is a little bit tedious. So one trick is to solve for the final velocity first. And what equation would relate that is this equation. So then you would say v squared is 1.2 squared plus 2 times 0.08 times 1. And then you can solve for v. And I will be very more careful so I don't have more mistakes in my math here. I get 1.265 meters per second. Okay? Now, how is that useful? Because then I can use v equals v0 plus at to then solve for the time. Okay, instead of using this quadratic. You will get the same answer. If you want to use it as a math exercise, you can confirm to yourself you'll get the same answer. Times t, and then, but this one is just easier to solve for the t. You're going to take that, subtract 1.2 divided by 0.08, and I get 0.81 seconds. And so that's the amount of time to go from there to there. If you had done the quadratic for this equation, You should get one of your answers to be 0.81. The other one, there's two solutions with quadratics, by the way. One's positive, one's negative in this instance. The negative one you kind of ignore because like the time being negative doesn't really make any sense. Okay, so I hope that was helpful. I hope that, as you can see, this is a complicated problem. But this is why I emphasize this process of listing out the variables and try to understand that idea of like, what are the knowns, what are the unknowns? I need 3 known quantities, and that's the idea of problem solving that I'd like to instill in you when you're doing even more complicated scenarios of things like that. Now, there's other ways that are shortcuts, that are faster. So if you're working on speed, that's a different thing. But for right now, for conceptual, this is probably the most straightforward way to solve it in terms of just understanding the process of how we solve problems. Okay? So if you guys have any other questions, this is a great question, by the way. Thank you for sending this. If you guys have any other questions, please do submit it. I'm happy to and maybe I'll pick it as the question of the week.